Rupali and Alex, who bring decades of combined cybersecurity experience over both blue team and red team disciplines. And today they'll be speaking about Terraform and how to exploit Terraform vulnerabilities by taking advantage of custom provider modules. Then they'll show how to fix them. The title of their talk is Terraform Unleashed, Crafting Custom Provider Exploits for Ultimate Control. Please give a warm welcome for Rupali and Alex.
Hello everyone, my name is Alex Foley. Just to start, I want to thank Rupali for inviting me on her talk with her research on this topic. Rupali and I have worked for many years together, both on combined projects and independent projects. And as it says in my bio right here, I do a bunch of, I operate as the virtual CISO of multiple companies. So I have a lot of optics into those organizations and how they operate. So it gives Rupali and I an interesting standpoint between doing assessments and looking at organizations to understand how they work under the hood and how they're implementing Terraform. And just to sort of start at a very base level, Terraform, I realize a lot of you understand what Terraform is, but let's talk about this just for a second, right? So Terraform is infrastructure as code. For a long time you used to stack servers, then you were mashing buttons, now everything's Terraform. So Terraform defines the infrastructure. And because of that, it needs to have a very high level of privilege to implement that infrastructure. So there's a conversation, or there has been a conversation for a long time about all the libraries and all of the supply chain attacks. And there isn't as much focus on these providers and insider threat issues with implementing people's own providers inside of your code, running as the top level user. So within AWS, if you're implementing this, you could wind up deleting backups, deleting infrastructure. You could do a lot of damage with these providers. So from there, I'll hand this to Rupali. Okay, and then who this talk is for, right? So there's sort of two sides of this, and Rupali is on the left here, pen testers, red teamers, people who are interested in understanding how to break into these systems and elevating their privileges. And then from my side, a little bit less technical, a little bit more about what to do. How do I handle the problem? How do I fix this? How do I prevent a malicious insider from doing this sort of activity? Also, depending on what sort of Terraform I'm dealing with, right? We're doing a Terraform Cloud, Terraform Enterprise, the open source. There's different ways that this can all be implemented as well.
Thank you, Alex. Okay. Before we head into the talk, I think I wanted to give one disclaimer that the attack scenario that we're going to talk about today, so I'm going to demonstrate with Terraform Enterprise, but keep in mind that if you guys are using open source Terraform as a part of your CI/CD pipeline, all of these account takeover attacks that I'm going to demonstrate is going to be relevant to your CI/CD server. That means wherever you are hosting your Terraform binary. So if you are using a Jenkins and as a part of your CI pipeline, you are using an open source Terraform which get executed in your CI server, then all of these attacks will be applicable to the CI server rather than the Terraform Enterprise. So for our example in this talk, I took examples of Terraform Enterprise and the account takeover, like how you can gain access to the account where Terraform Enterprise as a binary has been hosted. So this is a basic architecture. So Terraform Enterprise is definitely an enterprise product, like enterprise grade product. Majority of the people and organizations uses that for infrastructure as code. How it works is it is a bit different than Terraform Cloud. So what it does, HashiCorp gives you a Terraform binary. So majority of the developers are basically they will have access to this Terraform UI. That Terraform UI, it will be connected with your any kind of VCS integration. Like it could be a GitHub, it could be Bitbucket. So imagine yourself, wherever you are hosting your Terraform Enterprise, you can host it in AWS or Azure. So in this example, I took an example of AWS itself. So this is hosted in over here. In this AWS account is basically the AWS account where Terraform Enterprise is getting hosted. So they give you a Docker binary which hosts basically the application, which is this TFE application, which hosts this web app for the Terraform itself. And over here, this is hosted on an Amazon EC2, which is a Linux server. Terraform states the Terraform state files as a part of your S3 storage, which is over here, and it also interacts with the DynamoDB for the state lock mechanism. So state lock mechanism is like in Terraform we have different workspaces, right? So workspaces defines that whatever the configuration you are provisioning, where it is getting stored and where it's going to get executed. So every instance of Terraform deployment will have basically a workspace associated with that. So if two users are provisioning the same code for the same AWS account for under the same workspace, right, it will be gonna create a race condition. Hence, Terraform Enterprise uses DynamoDB state mechanism and it queues the job so that when a user performs a Terraform plan, it queues the job. It creates a lock on the DynamoDB on the state itself, and it queues the job so that there is no implications on the race condition for two people performing the Terraform plan on the same AWS account itself. So how it works? So when a developer pushes the code, so like any developer who have access or who is responsible for creating the infrastructure for the company itself, they pushes the code to the Bitbucket or GitHub, or you can probably do the same thing from your Terraform CLI. Terraform has the binary, you can just download it and run it from your local machine. So any of the things will work. It has three different integration level. One is your VCS driven integration, which is basically works on the GitHub actions. Second would be using Terraform API, which you can integrate as a part of your CI/CD server. And the third one would be using your Terraform binary directly from your machine itself. So you write your code, you save that in a specific directory on your machine, and then you get into the Terraform Enterprise and run your code. So when you run that, so what happens in the background itself? So let's have a look into that. So this is a very basic and simple Terraform code which is using AWS as a provider, and this is just used to provision and simple S3 bucket. So let's first understand that how providers work. Before we get into that, how do we write into a custom provider? Okay, so in order to provision this code over here, so you can see that in the first block of the required providers, we have HashiCorp/AWS. So HashiCorp basically has three different kind of providers. One is the official provider, one is a partner provider, and there are other community providers. Like community providers are the providers which are written open source. Like HashiCorp does not take the responsibility of whether they are malicious or whether they are secure. HashiCorp has HashiCorp owns the security for the official providers and the partner providers. So AWS is one of the partner providers and it's not HashiCorp official. So yeah, so for every Terraform configuration you write, you first in the first block you have to basically define that what provider you're going to use. So that is why required provider block stands for. So yes, so as a part of this code, you can see that the second block defines the different variables in the AWS itself. That what region you're gonna spin up your S3 and what is the name. There are certain variables that you have to define, and in the last over here you can see that you have to provide your access key and the secret key, because Terraform Enterprise is an outsourced application, right? It does not know how to authenticate to your AWS account where you're gonna provision your resource. So you have to give some kind of identity using which they can which the Terraform can use to provision the infrastructure in that specific AWS account, right? So yeah, so that's what the first step is. You first in order to provision the code, the user logs into the Terraform Enterprise first and provides the AWS credentials or the account for the resource provisioning. Then it performs Terraform init, as if you can see in this small screenshot. So upon the Terraform init, what happens is Terraform spins up the worker container in the TFE AWS account, which is basically the infidel short-lived container. So this container gets spinned up every time you wanted to perform a Terraform plan or a Terraform apply, or like any kind of a Terraform job you want to schedule. It creates a short-lived container which does the job, and after it does the job, it gets destroyed after that. So yeah, so coming back, once you do the Terraform init, the Terraform Enterprise spins up a worker container in the Terraform AWS account and download the required providers specified in that provider block. So in this case, it will download the AWS provider to that Docker container, infidel container itself. Then during the Terraform plan, the Terraform API zips the IAC code and provided authentication credentials as a part of the Terraform binary and stores it over the Worker container. So it basically makes an API call using the Terraform Enterprise application, which basically zips off your infrastructure as a code, whatever you have written. It either takes it from your Bitbucket or take it from your local machine if you are using Terraform binary. It takes your AWS credentials and it downloads also a Terraform binary onto the container. So those are the information will be available on that small infidel container, which will be created which is a short-lived container. It also performs, as I mentioned previously, it also performs a state lock using DynamoDB, and because of that, the EC2 wherever the Terraform Enterprise is hosted needs to have a privileged access on the DynamoDB as well as the S3 bucket itself. It also downloads the Sentinel policy. So people who are familiar with Terraform understands that there is a concept of policy as a code. It could be either through Sentinel or it could be either through OPA. So if you are using Terraform Enterprise, it by default gives you the ability to have the Sentinel policies in place. So how does the validation work? So it also downloads a copy of your Sentinel policy onto the container where it validates your Terraform plan with the Sentinel policies before the deployment itself. During the Terraform plan, so this is basically one screenshot of Terraform plan, how it does. So during the Terraform plan, once the Sentinel policies are validated against the Terraform plan output, the Terraform generates a newer set of credentials using the provided AWS credentials in the Terraform file, which will be used to provision the resource in the client's AWS account itself. So this is one example of AWS, but in other providers, like if you are creating a custom providers, you can define what kind of authentication mechanism you're going to use for that. So mostly in AWS, normally the developers has given a read-only access when they provision their AWS S3 credentials, and after the Sentinel validation, the Terraform binary itself performs and commands to generate another set of credentials using AWS S3's assume role, which is basically highly privileged credentials, somehow similar to have the admin rights, and that is used to provision the resource in the client's AWS account. So once the apply is completed, the Worker container stores the generated Terraform state file over the S3 bucket and then destroys the container. So this is how a Terraform lifecycle works. So understanding that, summing up that what exactly is a Terraform provider. So Terraform provider is basically a Golang binary. It's just an executable, right? Like if you are hosting your Terraform Enterprise application in Windows, you could prefer to have a executable which is Windows as a container. You could also have a Linux executable as a part of your Terraform provider itself. So to say that Terraform providers are basically binaries which are executables, and they interact with the provider APIs. So Terraform as a binary doesn't know when you provide an action and say that, oh, go spin up an S3 bucket. It doesn't know that, right? How to do that. So when you download basically the AWS provider, the Terraform binary talks to the AWS provider executable over an RPC call, and then it gets to know that, okay, I have to use this AWS API to generate this S3 bucket with this kind of resource configuration. So that's how it works. So over here, so onto the Worker container, imagine that there are basically two binaries. One is the Terraform binary, and one would be the provider binary, which will be consumed by the Terraform binary to spin up the infrastructure. So yeah, this is how it works. Hope there is a lot of theory with that. Let's get into the risk. So what is the risk then associated with Terraform provider? So first of all, Terraform binaries are executables which can be downloaded onto the infidel container during the Terraform init. So imagine yourself, you are basically downloading executable, which could be potentially malicious if you are downloading from an open source repo itself, and you are directly downloading into the container which has the highest privilege in your AWS account. So if that container is not rooted or not hardened, it can get the host machines like on the EC2's file system and get access to the EC2's STS credentials and get access to the S3 and the DynamoDB as well. So S3 and DynamoDB store the state files. So the state files have all of the information. The unfortunate fact is by default, the Terraform state files are stored with default AWS encryption. That means it does not have right now the capability to use a custom vault or HSM based key to encrypt the state files by yourself. It uses the default AWS server-side encryption. That means if the EC2 has the IAM access, where it can decrypt as well, like it can download the decrypted object of the state files. So the attacker can download the state files or delete the state files or modify the state files as well. So the second factor is the Terraform provider runs with the highest privilege on the worker container, and hence have access to the all-mounted file system as well as the AWS stage credentials of the Terraform worker container. So the Terraform worker container needs to have a read-only privilege to the S3 bucket and the S3 and RDS instance where the Terraform state file gets stored as a part of the application. So imagine yourself, if you are going back to this slide, it's right? So this developer by default does not have access to this AWS infrastructure. He is just responsible for spinning up the code or writing the code to the Bitbucket. But if this developer pushes or uses a malicious provider, which I'll show you the example later, and then he is able to read all of the state files which belongs to different clients and not just limited to this AWS account. That means he can extract all of the vault secrets, credentials, infrastructure information of all the hosted AWS accounts for the specific organization. So that is the second risk. The third one, in a scenario where multiple providers are invoked for a specific as a part of the specific Terraform plan, both the providers gonna have the access to the Terraform Enterprise environment variables and to the host file system. That means, so sometimes when you are spinning up AWS infrastructure, you might also want to, like if you're spinning up an EC2, you would also like to by default install certain agents, like could be a EDR agent or it could be your AV agent, or logging mechanism. So you also want to automate that part. You don't want to, okay, I spin up the EC2, then I go back and install them manually. So this is not how it works. So in order to get those things installed, you have to write a custom provider, or sometimes the vendor itself, they provide their own providers. So that means as a part of the Terraform plan, both the providers going to be there as a part of the Terraform plan itself into the ISA. Then that means if I am using some agent for installation, so that provider also going to have access to the environment variables of that specific container. So that means if that one is malicious, let's suppose I'm using Datadog, and if that Datadog provider is malicious, he's going to have access to my AWS stage credentials, which have admin rights, and then can create a call or make a call to any of the APIs hosted to their server to exfiltrate those AWS stage credentials and send it to the attacker. Because both of the providers are actually admin onto the container, and they will have access to each other's environment variables as well. Okay, so coming to the attack, like how do I then create a custom provider? So as a part of the red team or a pen test engagement, imagine yourself, you have been given an infrastructure. In a red team scenario, you have been given an assumed breach scenario where you have a developer access and you have to take over your complete organization's AWS account. How do you do that? You just have access, just a developer access. You can do push the code as the infrastructure as a code, just to deploy your application just as a developer, right? So how do I do that? With the custom in the first one over here, right? I'm trying to create a custom provider that can gain access to the host machines file system, which is basically the EC2 where the Terraform Enterprise is hosted. So that will be gonna be my attack path. And in order to have that, I need to have a provider that can interact with the host OS operating system and execute and let me read the file system of that EC2 itself. So in order to do that, so Golang basically supports two libraries, which is one is import exec and import syscall. So these are the two modules that I can use as a part of the Golang to create my provider code. So this is one sample example of one of the providers which I have created. So there are two functions over here. So this function basically lets you read the environment variables as a part of the Terraform container. And once you do that, once you write that, you also have to map those functions to your Terraform provider, so which is basically over here. So once that's done, you can just go ahead and you build your provider. Then how do you use that? How do you attack that? So this is one of the Terraform code that you can write. Over here, wherever you are hosting that provider itself. So you can provide that path over here. It could be your GitHub, or it could be if you are just putting it on your local machine, you can just give local / the provider name that you have created over here. And as a part of this, over here, I'm trying to read the file system of the /etc/password, which is basically the Linux file system. And over here, when you execute, you can see that I'm able to get access to the host machine's file system, and I can get access to the /etc/password directory. So that is one. This is okay. So this is the second example where I'm trying to create a custom provider that has code execution capability onto the container. Yeah. So I actually didn't have to do that because somebody already have done that, and this is one of the providers you can utilize for your test. This is the GitHub link for that provider. So this is the code using which he wrote a function, using which you can basically interact. You can write a code that can interact with your the container itself. So any command you will pass as a part of the provider will get executed onto the container. So this is how. So if you're going to use that, so this is the code this is the Terraform code that you have to write as an attacker. So yeah, so this is the source, and as a part of that, if you want to have an in-block reverse shell, so you can pass it as a part of the command, and you will get a reverse shell for that. This is one of the first interesting blog posts that I could find for attacking using a custom provider, which I have used in some of my red team engagements, and that gave me a real good shit out of that. So just go and try out of that. What else? So what else can we do while coming to the exploitation, right? So yeah, first thing, you execute the command from the Terraform container. That means if the container is not sanitized enough, you get access to the file system. Provisioning highly privileged access roles. So imagine yourself now so as a developer, I don't have access to to the AWS account where I want to provision the resource, right? I have to go through those Sentinel policy validations in order to make sure that my resources are not highly privileged. So, but if I'm a malicious developer, so I can leverage upon these providers, and then using which I can exfiltrate the exact AWS HTTP credentials which are going to be used, and then I can export that to my dev shell or CLI, and can directly provision the resource from there, and no need to have to go through the Terraform route itself. So using that, basically I will bypass all of the Sentinel policies, so that lets me create, if I want to create a highly privileged IAM role for a persistent access, it gives me that feasibility itself. Exfiltrate vaulted secrets from the Terraform container. So many organizations store any kind of database secrets as a part of the vault, which gets into the Terraform during as a part of the Terraform run, and the developer does not have access to that. But if you can read the environment variable of the container, you can exfiltrate all of those Terraform secrets or the vault secrets of the database itself. So that is another attack path that you could channelize. Manipulate state files, resulting in deleting resources of existing cloud accounts. So imagine yourself, you got now access to the state files, you delete those state files, right? That means the Terraform Enterprise doesn't know what is the current state, or if you tamper the existing state files and make it to null, so it's then for the next Terraform plan, whenever it will happen, it will understand that, okay, now I don't have anything as a part of my Terraform state to create. So it will go ahead and destroy the existing infrastructure which has been provisioned using Terraform Enterprise. Gain access to the PIA data in production account. So yeah, so basically if you have a highly privileged role, as an insider attacker, you can create an IAM role or to exfiltrate PIA data from your production account. So that is another attack path that you could look for. And supply chain threats and this also inculcate that supply chain threats to organizations using malicious providers. So many of the organizations that I have worked with doesn't understand that every time they are using open source providers, that needs to go through certain scans, because normally when you do AV scans or normal scans, it will not detect the Terraform functionalities. Like imagine yourself, you are executing as a code as a part of a Terraform provider. The EDR doesn't understand that this is malicious, right? It will understand that this is running as a part of the Terraform. It is a valid application itself. So then this attack techniques will basically enable you to perform EDR evasion. Like it doesn't detect for the EDR, it is legitimate even if you have it on your EC2 itself. Okay, another interesting thing. So people who have attended last year's Cloudflare talk, so there was a conversation about exploiting Terraform using provisioners. So the question is, why are we using providers and not provisioners for the exploitation? Terraform by default has local exec and remote exec capability as a part of the Terraform provisioner, which helps to execute commands again on the same Terraform infrastructure itself. But the catch is, if as an enterprise organization I'm using a Sentinel or an OPA, so every time you have to invoke a provisioner, it has to be when you are performing a Terraform apply. And before every Terraform apply, you can kick in, so as an administrator of organization, I can write Sentinel policy over here, like this is a snip set of the Sentinel policy. So you can block such attacks. But if you're using a provider, it runs as a part of a Terraform plan. So nothing in the world gonna block you for that. Because as a part of that, as a part of the Terraform plan, that Sentinel only kicks in once the plan is completed. So that means any code that you have written as a part of your Terraform plan gonna be executed as a part of the Terraform plan before the Sentinel kicks in. So that as an attacker gives you the privilege to execute and gain access. So that's why we are talking about providers and not exploiting the Terraform infrastructure using provisioners. With that, I will hand over to Alex. Yeah.
Hold on a second. Thank you. All right, in just a few minutes on the defense side of things, we're a little tight on time. So, need to take a look at these providers, the third-party providers, and what's the process to do that, right? So we're looking for known antivirus, known malware. As Rupali said, it's not necessarily something that all the scanners are going to pick up, so you need code review as well. You need to see what the impact is, what the blast radius is on the provider. Just make sure you can tighten up the controls as much as possible, and looking at outbound network communication to see if there's any sort of miscommunication that should not be there. So then sort of starting up at the top right, reiterating you want to do some kind of signature-based detection against it, some sort of antivirus, anti-malware, whether it's on the developer workstation, in addition to something in the CI/CD pipeline. Manual code review always sounds like a good idea. In practice, it's not always the most amazing thing. But looking, teaching your team how to look for this and how to acknowledge, hey, why did someone add a provider? Why is someone adding a new provider or making a custom provider? And then, dynamic simulation, taking a look at what the provider is doing in production to see if there's something that shouldn't be there. And then semgrep, so looking at things inside the CI/CD pipeline and an automation and working that through. And from my perspective, you need this in place. You need something to handle this. There are not a lot of open source or commercial tools to sort of hit this corner, but hopefully from some of the research that's done here, we can work towards that. And this here is just a list of some of the community providers that may or may not have problems and people injecting malicious code into them. So overall, you've got attack types, right? You've got the third-party providers. You've also got the insider threat problem. You've got to look at both of them sort of in an independent light. One with automation where possible, with manual review as well. And so you've got to work through training, work through detection, and work through the processes. And I think we're right at time, so this is good. I also want to thank the AxleNet security team for coming out with us today.